Okay, hello guys. Today our topic is about recurring decimals in the IGCSE Mathematics. Okay, so let's move into the first slide of today's our lesson. Okay, so this is about notations and concept. Okay, and you can find here a notation for the recurring decimals. We can using some dot on it. Like here we have 0.3 dot, and we call this dot a recurring symbol. So if here is a dot above 3, that means there's a lot of 3 after these 3, and it's like this. Okay? A lot of 3, and there's unlimited 3 after this. So we can call this recurring numbers. Okay? It is using a 3 to make a recurring. You can just consider it making a loop. Okay? And here you can find the decimal numbers. Here's 0.121212. Okay, for every decimal places, there's 1, 2, and then make a recurring. So we can put 2 dots above 1 and 2 like this way. Okay, to arrange for these recurring numbers. And here you can find there's another interesting numbers right here. It's called 0.1234, 234, 234, 234. So we said, oh, maybe here 234 is a recurring, and before this there's a 1. So we write down as 0.1234 and 2 dots above 2 and 4. That means between 2 and 4 there are 2, 3, 4, that there are a repeating part in the decimal numbers. Okay. But that's about the notations and the concept. I guess maybe you can just try to solve for these problems. It's very important for our notation and symbols. Okay. And here, there's some questions about the how to changes like recurring symbols into total, maybe fraction numbers, or also you can just consider it as maybe for just writing down into decimal places. Okay, so maybe here the question is convert 0.7. There's a recurring symbol above 7 to a fraction. Okay, so how to switch it into the fraction? Here, I'll give you the example, okay? So here we can first write down the numbers as this kind, as the decimal places, x equals to 0.777, all of 7 after the dot, okay? And you can just times it 10. So you can find after times the x become 10x, and this value also has to times 10, right? So here it becomes 7.7777, a lot of 7 after the dot. Okay, so we knew that recurring the decimals means there's a lot of and there's a repeating part of this. So we can say there are a lot of or unlimited value for the 7. And there is also for unlimited numbers for 7. Okay, so their numbers equals to each other. So you can make a subscription. Okay, so 10x minus x, you can find that this part minus this part only relieves 7, right? Okay, so then we can write down like line x equals to 7, and then you can write down as x equals to 7/9. Okay, so this is for the method to do this. Okay, every time you can just try to times for a value and to make a equation and to then find it about the correct value. So this like this way. Okay, and you can find 9x equals to 7 because this can be deleted together. So only 7 be left. Okay. Okay. So another example like here, if you want to convert 0.18 and there's a recurring symbols above 1 and 8, and you can first write down the value of this number, like here, x equals to 0.18, and 18. Okay, a lot of 18 after this. And then because here are 2 decimal repeated, okay? So if you're just using the method we just had before, if you just times 10 before x, like 10x equals to 1.81818. To compare with x, you can find is 0.18181, right? You can find the decimal places doesn't equal to each other. So we cannot times 10x. Because we knew that there are 2 numbers repeating each of the times, so you can just times 100 for a try. So you can maybe times 100x, and you'll find that the value becomes 18.1818 and 18, right? You'll find that maybe here for each decimal places, maybe here 18, 18, and here is also for 18, and 18. Okay, so you can just making a subscription, and here you can just using 100x minus x, and you'll find that here they're the same, right? 1/8, and here's also 1/8, here's 1/8, and here's also 1/8, because there's unlimited numbers after the dot. So 100x minus x equals to 18 minus 0, and the decimal places just been deleted, right? So here is 18, and you can say x equals to 18 over 99, okay? And the answer final here is 2 over 11, okay? Okay, this is for these problems. And here, another example, like here, to convert 0.43, only 3 repeated, okay? So first you can try to write down the x value, and then you can try to times 10, right? So here's 10x, and you'll find the answer here is 4.333, right? 4.333, a lot of 3 after this. And also you can just times 100x, 100 before x, it becomes 100x, and the answer here is 43.3333, a lot of 3 after this, okay? So this is 100x. Then you can just using 100x to minus the 10x right here. So it's 100x minus 10x, and here it equals to 43.333 minus 4.3333, okay? And then you'll find that, oh, maybe here is being deleted, and 43 minus 4 equals to 39. So the answer here is 90x equals to 39. So x final equals to 39 over 90 equals to 13 over 30, okay? That is for these problems. I guess for you, you have to just remember how to times them, and maybe for times 10, maybe for times 100, okay? They can both be used in such problems, okay? Okay, and here are some problems and challenges for you to do. So maybe you can take your time and trying to solve for this problem, please. Okay. So let's do these problems together. Okay, if you don't finish your homework, you can just try to pause the video, and then after finishing it, you can keep on going. Okay. So the first question is convert 0.5, the recurring number or recurring dot is above 5, right? So we knew that for the first problem, the number x we can written as 0.5, a lot of 5 after this, right? Like this way. And then you can try to times 10 before x. So it's 10x equals to 5.5555, a lot of 5 after this, right? And then you can using 10x to minus x, so it is 9x, right? And here, 5.555 a lot of 5 minus 0.55 a lot of 5 equals to 5, right? Like this. So you can then try to set, oh, maybe here x equals to 5 over 9, right? 5 over 9. So here is for how to change this into the fraction numbers. And for the second problem, 0.45, you can also try to first write down the x value, 0.45, a lot of 45 after this, and then trying to times 100, right? Because there are 2 decimal places after 0. So 100x right here equals to maybe 45.4545 and 45. And then you are trying to using 100x to minus x, and the answer is 99x equals to 45, right? Because these places can be deleted, right? Okay, so for x equals to 45 over 99, and then you can over 9, it is 5 over 11, okay? This is the second problem. And for the third problem, we knew that maybe there's only 7 to be repeated, so we can write down as 0.27277, all of 7 after this, and then you can just try to times 10, because 10x equals to 2.77, all of 7 after this, and then you can try to make a picture like here, 10x minus x equals to 9x, and 2.77 out of 7 after this, minus this value, and we can just delete it like here. Okay, so the final answer equals to 2.7 minus 0.2 equals to 2.5. So finally, x equals to, maybe for, I guess is for 5 over, maybe for 5 over 18, right? This is the third problem. Okay, and for the fourth problem, let's maybe take a look for this. Calculate 0.3, here is a dot on this, and 0.6 about other dot on this, right? So we want to calculate this, right? So you can first just trying to switch both of them into the fraction numbers, okay? So for x equals to 0.3, there's a recurring symbols above the 3, and you can set it equals to 0.3, a lot of 3 after this, right? And then you can times 10. So 10x equals to 3.3, a lot of 3 after this. And then you can using 10x minus x equals to 9x equals to 3. Okay, so here x equals to 1 over 3. Okay, That's for the 0.3, there's a recurring decimals or a recurring dot above the 3, okay? And for y maybe equals to 0.6 and there's a recurring decimals, right? And then you can write down like 0.666, a lot of things after this. And then you can times 10y, right? 10y here equals to 6 point, a lot of 6 after this. And then you can use in 10y to minus y equals to 9y. Here is 6, only 6 after this. So y equals to 1, maybe here is 2 over 3, right? So after using these two ways to switching x and y into two fraction numbers, you can add them together, right? So we can say here the 0.3 plus 0.6 equals to 1 over 3 plus 2/3, right? And the answer is 1, right? Okay, so maybe here I can have a question. So, teacher Mai Lin, why is it two decimal places are added together and it forms a 1? Maybe you have this question, okay? So maybe we can try to first consider that here, like this is 0.3, a lot of 3 after this, right? And this is 0.6, a lot of 6 after this. And then you can add them together. That is 0.999, a lot of 9 after the 0, right? So you'll find for this 9.999, it's very, maybe for approximately equals to 1, right? You can find that there's a distance between this value and 1, that is 0.000, a lot of 0 and 1. So you can just consider this as a very tiny value. This is very small and very tiny. Okay, so we can consider it just equals to 0. So here, 0.99 plus 0 equals to 1. That means this value maybe just equals to 1. Okay. So this is a consideration about the limitation, and maybe for next lesson, we will just learn about for limitation. Okay, when you are learning AS level, or maybe you are trying to learn some other further mathematics, you are get understanding about what is a limitation and what is maybe for all of this and the recurring numbers, how to making them approximately equals to integers. Okay. So that's for today's lesson. I hope you can just understand it for here and also for the challenge. It's a little bit difficult, okay? So maybe see you next time. Bye.